Hello everyone. Today I am delighted to present on a fantastic and powerful optimization technique and colony optimization or SEO. My name is Manas Pratim Kashyap and I am a MTech second semester student from the Department of Electrical Engineering at TISHU University. Ant colony optimization is a metaheuristic technique inspired by real ants targeting discrete optimization problems and exploiting self-organization principles. Ants are social insects that lives in colony and their collective behavior, particularly for their foraging and pathfinding, provides the core inspiration for SEO. To provide some content about these incredible insects, let's look at some facts. The total species, there are an estimated of 13,800 to 22,000 species of ants. A queen ant can live up to 30 years, while a soldier ant's lifespan is around 3 years. Ant lives in colony with an average colony containing thousands of individual ants. Some super colonies can even house up to 300 million ants. Ants do not have ears, they perceive vibration. Their primary modes of communication are through pheromones, sounds, and touch. Understanding the ant's life cycle. An ant's life cycle begins with an egg. If the egg is fertilized, it will develop into a female, otherwise it will become a male. The stages are egg, that's initial stage. Next we move forward to larva. This stage is immobile and the larvae are fed and cared for by worker ants primarily with liquid food. Next we move to pupa. This is a transformation stage. After that an adult ant is formed. At this mobile stage, adult ant consumes solid food such as pieces of prey and seeds. Within an ant colony, there is a clear division of labor. Number one is queen. The queen is the only ant in the colony capable of laying eggs. Next, move forward to male or drone. Their primary role is reproduction. Next, the female worker. These ants are responsible for various tasks within a colony. They typically forage, care for young, and maintain the nest. Next, we move forward to soldier ants. These ants have a crucial role, such as they protect the queens and the entire colony, attack enemy colonies, and also involved in collecting heavy foods. This visual representation of an ant provides insight into the organized structure. We can observe a distinct area. Queen lay eggs, where the queen deposits the egg. Next is storeroom, used for the storage within the colony. Next is a food storeroom, a specific area dedicated to storing food. Next is eggs caretaker, a section where eggs are cared for by worker ants. The fundamental inspiration behind the ant colony optimization algorithm is the foraging behavior of real ants as they search for efficient path between the colony and food source. The key aspect of this behavior is indirect communication and communicate through a chemical substance called pheromone. This pheromone signal allows ants to efficiently find the shortest path between their nest and food. The foraging behavior can be summarized as follows. Ants initially explore an area randomly. As they move, they release pheromones. When ants discover a food source, they tend to choose the path that has a stronger pheromone concentration, as this indicates a more frequently used and likely shorter route. However, the shortest path accumulates a stronger pheromone concentration. The double breach experiment demonstrates an ant intelligence and the effectiveness of pheromone-based pathfinding. This experimental setup involves a nest connected to a food source via two bridge. Experiments are conducted with either equal length branch or different length branch. In case of an equal length branch, initially ants choose a branch randomly. However, due to positive feedback, also known as autocatalysis, The ants eventually converge on a single branch. This means that as more ants use a path, more pheromone is deposited, attracting even more ants to that path. Next one you come about the different length branches. In this scenario, ants traveling on a shorter branch returning to the nest more quickly. This faster returning rate means they deposit pheromone more frequently on a shorter path. Next, we understand about the importance of pheromone evaporation. It prevents the colony from becoming trapped on the suboptimal path. Without evaporation, pheromone trails on longer or less efficient path would persist indefinitely even if better paths become available. Here figure 3 illustrates the experimental setup when the short branch was added. To apply the principle of ant behavior to computational problem, we represent the optimization problem as graph. In this graph, artificial ants move between nodes along arcs, much like real ants move between the location. Figure 3 and Figure 4 illustrated the model where in this model a long branch or a short arc is used, and in this model each arc in a graph has the same length and a longer branch is represented by a sequence of these equal length arcs. It is used to solve the minimum cost path problems. The ant colony optimization is a powerful metaheuristic where a colony of artificial ants collaborates to find a good solution. This can be used to solve both static and dynamic optimization problems. In static, defined as a once and remain constant throughout the solution process. The classic example is traveling salesman problem, and in case of dynamic problem, this involves a quantities whose values change based on the system dynamics. Here we can examples such as a problem of net routing problems. Here is a picture for the traveling salesman problem, where a traveling salesman will move from the current city to the different cities and returning back to the same city. We will see in the next slide. In this case, consider yourself as a salesman and starting from your home city, city A, and you have a list of other cities B, C, D, E you need to visit. So, the objective of this problem is to visit each city at once, find the shortest possible route that accomplishes this, and finally return to the starting city. This problem complexity grows exponentially with the number of cities, making it an ideal candidate for heuristic approach like SEO. In this slide, we will see the stepwise. Here are the steps parameter we will use with the example. First of all, we will look into the initialized SEO parameter. Some of the parameters which will be needed in this using a problem: population size, maximum iteration, pheromone initial value, exponential weight, heuristic weight, and evaporation rate. And these are the parameters or assumptions we have taken just for an example. And construction and solution construction iteration will go 1 to 500. Next one will come position each end in the starting node. Here create and move from node 1 to, or say node I to node J with a probability of finding a moving from node I to node J. Considering the population size is 4, because we see that a traveling salesman problem, the salesman will go from the current city to the fourth city. So considering it at 4, repeat it until and build the best solution and compute the fitness value and update the best solution until it gives the optimal value. Applying the pheromone update, note that increasing level of pheromone will give the best solution and decreasing the level of pheromone will give the worst solution. This is an expression for pheromone updating equation. Tau ij is represented as the total pheromone deposited by the ant from moving a part I to j, and del tau is represented as the total pheromone deposited by k n, like n number of ants on a part ij, which can be if the ant k uses a curve I to j, then it will be k q by lk, where q is remains constant 1 by length, otherwise 0. Next, display the best solution. It will repeat until the maximum number of iteration completes. After that, it will show the best or optimal solution. Here are some of the limitations and advantages. ACO limitations is that it uses some more parameters such as alpha, beta, and rho. The advantage, it provides a better solution with fewer iterations. Despite the parameter tuning, ACO often excels at finding high quality solutions. Here the conclusion of this presentation. We have discussed all this in this presentation. Ants communicate indirectly through pheromones. The double pH experiment was demonstrated. Pheromone evaporation is a crucial parameter. ACO represents the optimization problem as a graph where artificial ants move between the nodes. It can solve the both static and the dynamic problem. In static, we discussed about the traveling salesman problem. Uh, Also discussed about the limitations and advantages. These are the references we have taken for the study. Thank you for your attention.